Okay, right now we're gonna increase level a little bit because we're gonna have a proper real circuit, and we are gonna try to find the current flowing on a certain resistance. And it's gonna take a bit of computation and put together some of the things we know, but it's gonna be fun. So let's start with circuit. Okay, so let's start with the power supply. It's going to be here. It's going to be our V1, and it's 1.5 volts. So this is going to be our power supply. Then we're going to have a resistance, which is R1, 75 ohm. Then we're going to have another resistance here. It's going to be our R4, and it's 75 ohm as well. And then we're going to have a node here with another resistance here called R3, which is 75 ohm as well. And another one here, which is gonna be our R2 and is 150 ohm. Then here we're gonna have a second power supply, voltage power supply, which is gonna be our V2, and this is gonna be 2.4 volts. And then here I'm gonna go all the way down to here. And as always, we're gonna have ground as a reference. So those are our data. And what we want to know is the current flowing across this resistance here. So the current flowing in R3. So to make our life easier, we're going to say that the current flowing in this direction here is I1. The current flowing in this direction here is I2. And the current that we are looking for, which is the one that flows down here, is I3. So I1, I2, and I3. And we're interested in I3. It's going to take a little bit to find out the current. So what do we know? Well, we know that the current entering, this is a node, right? So the current entering the node is equal to the one leaving the node, which basically means that we have I1 going into the node, and then we have I2 and I3 leaving the node. Therefore, since nothing is destroyed or created from scratch, I1 must be equal to I2 plus I3. So we know that I1 is equal to I2 plus I3. And we're interested in I3, but we don't know any of them right now. So, but we can find out, because if we actually know something about V1 and we know something about V2. Because V1, and we know the values of V1, but we know that V1 is actually equal to I1 times R1 plus R4 plus I3 times R3. So what we know is that V1 is equal of I1 times R1 plus R4 plus I3 times R3. And we also know that V2, the same thing can be said for V2. V2 is minus I2, because we are going in the opposite direction, right? So it's minus I2 times R2 plus R3 times I3. So negative I2 times R2 plus I3 times R3. So those are the two things that we know right now. And those are actually going to be enough because we can basically get I1 and I2 to then find out I3, and which is essentially what we want to know, I3. So we can start from this relationship here. So V1. So if we write it down, so we write V1 equal I1 times R1 plus R4 plus I3 times R3, right? We can basically put numbers in it and find out. So V1, we know what V1 is. It's 1.5 volts, so 1.5. We don't know I1, but we are about to find out from this relationship. So I1 times R1 plus R4. We know what R1 is 75 ohm, plus R4. R4 is 75 ohm. 75 plus 75. This is going to be plus I3 times, well, R3, but we know what R3 is. R3 is 75 ohms, so times 75. So again, what do we have? Well, we have 1.5 equal to 150 I1 plus 75 I3. And we're basically gonna get I1 out of this relationship here. So 150 I1 is actually equal to negative 75 I3 plus 1.5. So I1 is equal to negative 75 over 150 I3 plus 1.5 over 150. And we can actually simplify 75 and 150, which is like saying 1/2. So by taking this into account, we have now found out that I1 is 1/2 of I3 plus 0.01. So we're getting there, and we have found I1. Now we can use the second relationship, so V2, this one, to find I2. And then we can plug those two here to find eventually I3. So let's do that. So if we write again V2, the relationship we have for V2, so this one, V2, is equal to negative I2 times R2 plus I3 times R3. So from here, we're going to find out about I2. So V2, we know what V2 is 2.4. So 2.4 equal to negative I2, which we don't know yet, times R2, we know what R2 is 150, plus I3, which we don't know yet, but we want to find out, times R3, and R3 we know is 75. So again, what are we going to find out? Well, with a bit of computation, what do we have? Well, we have 2.4 is equal to negative 150 I2 plus 75 I3. So 150 I2 plus 2.4 is equal to 75 I3. So 150 I2 is equal to 75 I3 minus 2.4. So I2 is equal to 75 over 150 I3 minus 2.4 over 150. And we can actually simplify 75 with 150, which is like saying 1/2. And again, this gives us that I2 is equal to 1/2 I3 minus 0.016. So we are really getting closer to our final answer, because now we know I1, we know in terms of I3, we know I2 in terms of I3, and we know the relationship between I1, I2, and I3. So we can basically put those three together in a system of equation. So what I mean by that is that we're going to write the first three relationships. So I1 equal I2 plus I3, like so. Now we're going to write the second relationship. So I1, which we found out, is 1/2 I3 plus 0.01. And anyway, we're going to use the third relationship, so which we just found out. So I2 is equal to 1/2 I3 minus 0.016. And this is our system. And we're gonna try to solve this to eventually find, well, we just want to find I3, but as a side effect, we're going to find all the three currents. So I1, I2, and I3. So let's start from the very beginning. So, well, we know we can use this relationship in here. So if we plug I1 here, so what do we know about I1? And what we know is that I1 is actually is 1/2 I3 plus 0.01, which is equal to 1/2 I3 minus 0.016 plus I3. This one is going to stay the same, so I1 is equal to 1/2 I3 plus 0.01, and I2 is 1/2 I3 minus 0.016. Now I hate when I have to change page, but I kind of have to. Well, luckily I can stack them one on top of the other and get away with this. So again, computation wise, again, it's gonna be, well, 1/2 I3 minus 1/2 I3 minus I3 equal to negative 0.016 minus 0.01. I1 is going to be 1/2 of I3 plus 0.01. And I2 is 1/2 of I3 minus 0.016. Now, if we go on with the computations, we're going to have 1 minus 2, everything divided by 2, because of the common denominator here. I3 equal to negative 0.026. Then we would have I1, which is equal to 1/2 I3 plus 0.01. And we're going to have I2, which is 1/2 I3 minus 0.016. Again, we go on with the computations. So what we're gonna have is, well, we're gonna end up with negative 2 I3 equal to negative 0.026. Then we have, well, of course, it's silly to write 2 over 2, as is essentially 1. And then we have I1, which is 1/2 of I3 plus 0.01, and I2, which is 1/2 I3 minus 0.016. Now, if we go on again with the computations, what we're gonna get is, well, negative I3 is equal to negative 0.026. We also get that I1 is equal to 1/2 I3 plus 0.01, and I2 is 1/2 I3 minus 0.016. Now we could essentially stop here and say, okay, I3 is 0.026 or 26 milliamps. But we can actually also find the other two currents. As is a little bit of fun, let's go on. So I3 is 0.026. I1 is 1/2 times, well, we plug I3 here, so times 0.026 plus 0.01, and I2 is 1/2 times 0.026 minus 0.016. And if we go on again, we have that I3 is 0.026, I1 is 0.026 over 2 plus 0.01, and also that I2 is 0.026 over 2 minus 0.016. So again, I3 is 0.026, I1 is, oh well, it's 0.013 plus 0.01, and I2 is 0.013 minus 0.016. And going forward, we get that I3 is 0.026, I1 is 0.023, and I2 is negative 0.003. Negative because it's going in the it's going in the other direction. So, well, we were only really interested in I3. So we can say that I3 is essentially 26 milliamps. And this is going to be our final answer.